Right now you are sitting on a rock, hurtling through space at 67,000 miles per hour, and that rock is inside a galaxy. That galaxy is inside a universe. But here's the question that has haunted every astronomer, every physicist, every human being who has ever looked up at the night sky. What is the universe inside of? This is not a trick question. This is one of the deepest unsolved mysteries in all of science, and today we are going to explore it together. Before we can answer what lies beyond the universe, we need to understand what the universe actually is. The observable universe stretches 93 billion light-years across. That is everything we can see, every star, every planet, every black hole, every galaxy, all 2 trillion of them. But observable is the key word here. We can only see what light has had time to reach us since the Big Bang, 13.8 billion years ago. Beyond that boundary, we have no idea. Our telescopes go completely blind. It is like standing in a dark room with a single flashlight. You can only see what the light touches. But the room itself could be a small closet, or it could stretch on forever. So what do we actually know about the shape of the universe? This is where things get fascinating. For decades, scientists have been trying to measure the curvature of space itself. Think of it this way. If you draw a triangle on a flat piece of paper, the angles add up to 180 degrees. But if you draw a triangle on the surface of a sphere, the angles add up to more than 180 degrees. And on a saddle shape, they add up to less. Scientists have been measuring the cosmic microwave background radiation, the leftover glow from the Big Bang, to figure out which shape our universe resembles. And the answer they keep getting? Flat. Our universe appears to be geometrically flat to within the limits of our measurements. And a flat universe, according to the math, is most consistent with being infinite. Scientists have narrowed the possibilities down to 3 main theories, and all of them will genuinely challenge the way you see reality. The first possibility is that the universe is simply infinite. It just keeps going, forever. No edge, no wall, no boundary of any kind. If this is true, then the implications are almost impossible to fully grasp. In an infinite universe, every possible arrangement of matter must eventually repeat. That means somewhere out there, separated from us by an unimaginable distance, there is an exact copy of our Milky Way galaxy. And inside that galaxy, there is an exact copy of our solar system. And on a planet just like Earth, there is a person who looks exactly like you, with the same memories, the same thoughts, making the exact same choices you are making right now. In an infinite universe, this is not science fiction. This is a mathematical certainty. The second possibility is that the universe curves back on itself, like the surface of a sphere. Imagine you are an ant walking on the surface of a balloon. You keep walking in a straight line, and eventually you come back to exactly where you started. There is no edge. There is no cliff you fall off. But the surface is also not infinite. It is finite but unbounded. This is what physicists call a closed universe. If our universe works this way, then in theory, if you could travel fast enough in one direction, you would eventually loop back around and approach Earth from the opposite side. The universe would be like a giant cosmic video game, where walking off one edge of the map brings you back in from the other side. The third possibility is perhaps the most mind-bending of all. What if our universe is just one bubble, floating in an infinite sea of other bubbles? This is the multiverse theory, and it comes directly out of some of the most respected physics we have. According to a theory called eternal inflation, the Big Bang was not a one-time event. Space itself is constantly inflating, expanding at an incredible rate. And occasionally, small regions of that inflating space stop expanding and collapse into their own self-contained universes, like bubbles forming in boiling water. Our universe would be just one of these bubbles, and the sea of inflating space around us would be generating new universes constantly, perhaps infinitely many of them. Each bubble universe would have its own physical laws, its own constants, its own version of reality. Some might have different strengths of gravity, some might not have stars at all, some might have forms of matter and energy that we cannot even imagine. But here is where things get really strange. If the universe is expanding, what exactly is it expanding into? This question seems simple, but it reveals something deeply counterintuitive about the nature of space itself. The answer that physics gives us is both profound and unsatisfying at the same time. Space is not expanding into anything. Space itself is stretching. The universe is not a balloon inflating inside a larger room. The balloon is all there is. There is no outside. There is no container that the universe sits inside. The universe does not exist in space. Space exists inside the universe. When we ask what is beyond the edge of the universe, we may be making a fundamental error, like asking what is south of the South Pole. The question sounds perfectly reasonable, but it refers to something that simply does not exist. Some of the most brilliant physicists who have ever lived have wrestled with these questions. Stephen Hawking spent decades working on the no-boundary proposal, a mathematical framework suggesting that the universe has no beginning and no edge in the same way that the surface of the Earth has no edge. You can walk around the entire surface of the Earth and never reach a boundary. Hawking proposed that space and time work similarly at the quantum level. Meanwhile, physicists like Max Tegmark have gone even further, proposing what he calls the mathematical universe hypothesis, the idea that all mathematically consistent structures actually exist as physical realities. In this view, every possible universe that can be mathematically described actually exists somewhere. What makes all of this even more fascinating is that we may never be able to know the answer with certainty. Here is why. Even if the universe is finite, even if there is some kind of boundary or edge out there, the light from that boundary may never reach us. The universe is expanding faster than light can travel across it. Regions of space that are far enough away are receding from us faster than the speed of light. This does not violate Einstein's relativity, because it is space itself that is stretching, not objects moving through space. But it does mean that there is a cosmic horizon beyond which we will never receive any information, no matter how powerful our telescopes become. The universe may be hiding its own secrets from us, permanently and by design. We are a species that climbed down from the trees just a few million years ago. We scratched pictures on cave walls. We learned to farm, to build, to write, to sail across oceans we had never seen. We split the atom. We landed on the moon with less computing power than the phone in your pocket. We photographed a black hole 55 million light years away. We have mapped the entire human genome. We have built machines that can think. And yet, the most fundamental question of all, the question of what our universe is inside of, remains completely unanswered. Maybe we will find out in 100 years. Maybe in 1,000. Maybe never. But the fact that we are even capable of asking the question, that we can look up at the night sky and wonder what lies beyond the last star, that is what makes us extraordinary. That is what makes us human. This is Unknown Frontier, and we are just getting started.